You're welcome, and we are proceeding ahead with organic chemistry and looking at further examples on combustion of gaseous hydrocarbons. Now let us take a close look at this example. We are saying that 30 cubic centimeters of the gaseous hydrocarbon P we exploded with excess oxygen. Now normally this excess oxygen, we don't know how much of it is reacting and how much of it is not reacting. But we later establish that by the virtue of examining other sections of the question. We're even going ahead to say which is in excess, okay? Then the residual gas volume occupied 155 cubic centimeters on cooling to room temperature. Now remember, residual gas, we said residual gas contains unreacted oxygen, which we can also call excess oxygen, then plus carbon dioxide that has been formed. That's what constitutes the residual gas volume. When we talk of residual gas volume, think of unreacted oxygen or excess oxygen, then plus carbon dioxide formed. Now, we are saying that determine the molecular formula of compound P if its molecular mass is 54. Now, we need to be able or get ourselves acquainted with writing the equation of combustion of the gaseous hydrocarbon. For example, if we have this gaseous hydrocarbon, here is solution, CX that is the general equation. Actually, it is general for all hydrocarbons. The general equation of combustion of the gaseous hydrocarbon. Now, we have said that this is 30 cubic centimeters. This is what is reacting, and all of it is reacting. Now, maybe before I look at that, let me first look at this is 1 cubic centimeter. This is X. I'm looking at by mole ratio. This is X over 4 cubic centimeter. This is X cubic centimeter. This is Y over 2 cubic centimeter. By mole ratio. That one I'm obtaining it from mole ratio. So 1 cubic centimeter of the gaseous hydrocarbon P reacts with the X plus Y over 4 cubic centimeters of oxygen to form X cubic centimeters of carbon dioxide and Y over 2 cubic centimeters of oxygen gas. Now, but we know that it is a hydrocarbon being burned, and all of it is burning completely. So since it's burning completely, it affects the formation of all those compounds. First of all, it reacts with the oxygen to form this and form the other one. But not all of this can affect the other ones, because part of this is reacting and part of the others, and part of the hydrocarbon is not reacting. So since the hydrocarbons burns completely and affects the reactants and all the products, then we can multiply through by the volume of the hydrocarbon to see what we obtain. So this will give us 30 cubic centimeters, and this is 30 into brackets X plus Y over 4 cubic centimeters. This is 30X cubic centimeters. This is 15Y cubic centimeters. That is when we multiply through by 30 cubic centimeters. Now, we can go to what is called residual gas volume. Remember, we said that P were exploded with 200 cubic centimeters of oxygen, which was in excess. Then the residual gas volume occupied this 150 cubic centimeters on cooling to room temperature. So once we cool to room temperature, then we no longer have water vapor. Therefore, this residual gas volume only contains unreacted oxygen, which is excess oxygen gas, plus carbon dioxide form. So we can say residual gas volume should equal to excess oxygen gas plus carbon dioxide gas formed. That makes the residual gas volume. Now, the excess oxygen gas, currently we don't have it, but we can find it. Or we can say volume of excess oxygen should equal to what? Should equal to a total of total oxygen is 200. That is the total volume of oxygen used. Part of it reacted and part of it never reacted. But the part which reacted is this one here, because this is part of oxygen reacting. So I can say this is minus 30 into brackets x plus y over 4. Now the whole of this takes a unit of cubic centimeters. That is the volume of excess oxygen that remains unreacted. I'm looking at 200 because that is the total amount of oxygen used. And we're saying that out of the 200, part of it will react and part of it will remain unreacted. So the part which reacts is this one. We are obtaining this part of the volume which is reacting from the equation of reaction. So this is the part reacting. So when you subtract, you should therefore be able to obtain volume of oxygen that never reacted. Assuming that we know the value of x, we also know the value of y, we shall be able to find volume of oxygen that never reacted. Now, go back to residual gas volume. Sorry. Residual gas volume. We've already written its equations as volume of excess oxygen plus volume of carbon dioxide formed. So this one gives me 200 minus 30 into brackets x plus y over 4. Then this one is supposed to be volume of carbon dioxide formed, which is 30x. Yeah, that now gives me total volume of carbon dioxide. Total gas volume. Now, this one we can simplify it. We can simplify this one, and when we are trying to simplify it, we can say this is 200 minus 30x plus, no, this is also minus 30y out of 4, then plus 30x. So when we simplify that, we get 200 minus, this will cancel definitely with the other one, then 30 divided by 4, 30 divided by 4, we obtain 7.5. 30 divided by 4, we get 7.5 y. So now this one is volume of the residual gas, or we can call it residual gas volume. So residual gas volume is definitely 200 minus 7.5. Now, but I want us to go back to the question and realize that we said the residual gas volume occupied 155 cubic centimeters on cooling to room temperature. So that means the 155 corresponds to 200 minus 7.5. Therefore, we now have the right to look at the relationship between the two. Therefore, I can say these two are the same. That's the relationship between them. That 200 minus 7.5 y is supposed to equal to 155. So when you work out, collect like terms, 7.5 y should equal to 200 minus 155. Okay, 200 minus 155 will obtain 45 versus 7.5 y. So when we divide through 7.5, we should be able to obtain y equal to 6. Should be able to obtain y equal to 6. But I want us to remember that the hydrocarbon has unknowns of x and y, and one of them has been determined. After determining one of them, then we can go ahead and determine the remaining part of the unknown. So, but I want us to remember that we said determine molecular formula of P if its molecular mass is 54. So therefore that means we can say this is the CxH6 equal to 54. Atomic mass of carbon is 12. So this is 12x plus 1 times 6 equal to 54. So this is 54 minus 6. When you press on the calculator, 54 minus 6 obtain 48. So this is 12x equal to 48. Then divide through 12x divided by 12 should get 48 divided by 12. So therefore x should equal 48 divided by 12. So that we obtain x equal to 4. Now, after determining the value of x and y, we can go ahead and say therefore the molecular formula of P is C4H6. That is the molecular formula of P. Okay, that's how exactly we can handle that question.